In this video, we are going to solve an example on the summing amplifier. The example says that we have this circuit with the summing amplifier with numbers. We have the feedback resistor as 250 kilo ohm. The resistance with the first source is 5 kilo ohm. The resistance with the second source is 25 kilo ohm. The bias voltage 15 and negative 10. It says the first part, find the output voltage in the circuit. If VA is 0.1 and VB is 0.25, then we will fix VB, and then we ask how large VA can be before the op-amp saturates, and then we do the same if we fix VA and we see how large VB can be, and then the last part we are going to repeat the same thing, but we reverse the polarity of VB. Okay, so basically let's start by writing the equation. Always start by writing the equations that you know. For the summing amplifier, this type of summing amplifier, V output equals minus RF over RA multiplied by VA minus RF over RB multiplied by VB. RF is 250, RA is 5, so this will be minus 50 VA, and then RF over RB will be 10. So minus 10 VB. So this is the equation of V output now. Let's keep it with us. Now, the first part, it asks you if VA is 0.1 and VB is 0.25, what will be V output? So all what we need to do is substitute. Of course, we assume before we started to solve this, we assume that we are working in the linear region, and this is the assumption that we always assume in the beginning, and of course, it should be an ideal amplifier. We assume it's an ideal amplifier and we are working in the linear region. If we are not working in the linear region, this equation will not be valid. Okay? So by default, we assume we are in the linear region and we have to check. After we finish, we have to check. How to check? We'll see. Okay? So V output here, if VA is 0.1, we substitute. It will be minus 50 multiplied by 0.1. minus 10 multiplied by VB, which is 0.25. So this will give you minus 5 minus 2.5. It will give you minus 7.5 volt. Now we check. How do we check? V output must be within the range of the bias voltages, right? Within the range of the bias voltages. So it should be higher than negative 10 and lower than 15. And this is the case. So V output here is between negative 10, higher than negative 10, and lower than 15. So our solution is correct, and we are in the linear region. So we have to assume, and then we check by checking that V output lies within the range of the two bias voltages. Okay, next. It says if we fix VB to 0.25, how large can VA be before the op-amp saturates? So, in order for the op-amp not to saturate, we need what? We need V output to be larger than negative 10, smaller than the positive DC voltage 15. So let's substitute V output from here. V output is negative 50. VA minus 10 VB, and VB here it says that we are going to fix it to 0.25, so minus 10 multiplied by 0.25 must be larger than negative 10, smaller than 15. Of course, this amount is negative, right? So we are asking about how large VA can be. So if VA, how large can it be, then this amount will be always negative, and we should care only about this side of the equation. But anyways, let's continue. So this is minus 50 VA, okay? Minus 2.5 must be greater than minus 10, here 50. We can take negative 2.5 to the other side, so minus 50 VA must be greater than or equal to negative 7.5 and smaller than or equal to 17.5, right? And then we divide over negative 50. If we divide over negative 50, the signs are going to reverse, and VA will be smaller than or equal to 7.5 over 50, which is 0.15 volt. Okay, and from the other side, if we divide over 50, it will be negative 17.5 over 50, which will be probably which probably will be 2.15. Okay, so I'm not sure about this. So 17.5 over 50. No, it's not 2. It will be negative 0.250. So here, since the question is asking of how large VA can be before the op-amp saturates, then we care about this part, because the maximum of VA is 0.15 volt. You have to indicate the unit, whether it's volt or millivolt, you have to indicate it. Okay? So this is the answer to the second part. The third part is very similar, but we are going to fix VA, and then we calculate how large VB can be. So if we fix VA to 0.1, this will give us minus 50 multiplied by 0.1 minus 10 VB must be greater than or equal to negative 10, less than or equal to 15. Then this will be negative 50 multiplied by 0.1 is negative 5. Then we take negative 5 to the other side, so it will be negative 5 here and 20 here. Then we divide over negative 10. The signs are going to reverse, and VB will be here half, and here it will be negative 2 volt. So the maximum of VB in this case will be 0.5 volt. The maximum will be 0.5 volt. And the minimum is negative 2. This is the maximum and the minimum of VB before the amplifier saturates. Then the last part, it says, what happens if we reverse the polarity of VB, which means that we connect the negative up and the positive down. In this case, the voltage here will not be VB, it will be negative VB. So this equation will give you a hint, and I will leave you to solve it at home as a homework. Okay? So in this case, if we reverse the polarity, then the voltage here will not be VB, it will be negative VB, right? And the equation will not be V out equals negative 50 VA, negative 10 VB, it will be plus 10 VB, because it's negative 10 multiplied by negative VB, right? When we reverse the polarity of VB, it will be negative 10 multiplied by negative VB, which is plus VB. And then you repeat all the steps that we did before for using this equation instead of this equation. I will leave this to you, and you can solve it at home. Okay, we'll see you in the next video, inshallah.